cosmic catastrophe in the age of Leo. And some of you may know the age of Leo as the Younger Dryas, or at least part of the age of Leo occurred during the duration of the so-called Younger Dryas. Interestingly, the beginning of the so-called age of Leo and the beginning of the Younger Dryas occurred within 50 to 100 years of each other, maybe even exactly at the same point. Of course, what I mean by the age of Leo before we get started is simply the time during which the spring equinox was transiting through the star constellation of Leo the Lion. I don't mean to imply any particular significance to that other than it just simply provides us with a chronometer by which we can actually correlate things in the sky with things on the earth. And during that period of time, from about 12,960 years ago for about the next 2,000 years, the vernal equinox was moving through the star constellation of Leo. Let's just begin here by going back almost 3 decades. It was kind of a milestone for me because I was invited to give some lectures. And so in March of the year 1996, I gave a series of lectures at Warren Wilson College in Western North Carolina. One of the themes of these lectures was the growing massive evidence for a major global catastrophe occurring somewhere around 13,000 years ago that wiped out many of the species of great megafauna that inhabited the Earth at that time, and had done so for hundreds of thousands of years. By the 1990s, when I gave these lectures, the evidence for catastrophic change events in Earth history was quite robust and well substantiated. Since the early 1980s, the majority of mainstream Earth scientists were accepting the idea that something profoundly catastrophic happened 65 million years ago or so that ended the reign of the dinosaurs. By the early 1990s, the majority of mainstream Earth scientists, geologists, paleontologists, and others were accepting the idea that the catastrophe involved, if it was not triggered by, the impact onto Earth of a giant asteroid. The acceptance of this radical idea came about as the result of the discovery of the giant buried Chicxulub astrobleme or star wound in the area of the Yucatan Peninsula, Mexico. But it also appeared that massive volcanic eruptions severely affecting the global environment occurred at this time as well. So there was a controversy between the impact camp and the volcanism camp as to which one played the greater role in contributing to the ultimate extinction of the great dinosaurs. So, however, I would maintain that it is not unlikely that the volcanism may have been triggered by the impact, or if the volcanism was already underway, it may have been intensified by the impact. Interestingly, Chicxulub impact site in the area of the Yucatan is at the antipode or of the source of the outpouring of the vast Deccan Traps lava floods that form the igneous province now comprising a large part of western India. Every spot on Earth has an antipode, or I've heard it's also pronounced antipode, but I think antipode is the more correct one. But every spot on Earth has an antipode, which is the point on the exact opposite side of the sphere. The idea here is that the tremendous shock wave generated by the powerful impact in the Yucatan would have traveled through and around the Earth's crust, converging on the exact opposite side of the planet with extreme force. In other words, the impact may have triggered the volcanic eruptions, which would have then added to the mayhem on Earth at that time. At this point, I think it was both the volcanism and the impact working together that really clinched the severity of this mass extinction event. And now, since the confirmation of at least one great impact event at the Cretaceous Tertiary or KT boundary, as we used to call it, now it's the K /PT boundary. Since the confirmation, it had provoked one of the most severe mass extinction episodes in Earth history. A considerable body of evidence has accumulated pointing to the conclusion that catastrophic impact events may have occurred with alarming frequency over time, and in the process have generated extreme climate and environmental changes and associated mass extinctions that accompany destruction of habitat. There have been 5 recognized, maybe 6 now, depending on whose data you're looking at, but there have been at least 5 recognized great mass extinctions since the dawn of life on Earth, in which a majority of species existing at the time were abruptly killed off. Each of the Great 5, which demarcates some of the major geological boundaries, has suggestive evidence pointing to the occurrence of cosmic impact at or near them. The greatest mass dying episode in Earth history is at the Permian-Triassic boundary of 245 million years ago. This event, or events more likely, came close to killing all life on Earth. It appears to have involved both cosmic impact and immense volcanism. The so-called Siberian traps, which is another great igneous domain on Earth, up in Siberia, seems to be associated with this particular geological and paleontological boundary. There have also been innumerable lesser extinction episodes that have decimated significant numbers of species, including the geologically very recent terminal ice age extinction that has the unique distinction of having occurred in the time of modern humans on the Earth. By the time I gave those lectures in 1996, my interest had already turned to the question of what role catastrophic events have played in human history. This idea had been an obsession of mine since the 1970s, when I began to believe that many of the striking parallels found throughout the world's great mythical traditions had behind them the memory of actual events. Especially was this true with the traditions of world destructions by giant floods and fires. I'd also, as a boy, been obsessed with dinosaurs well up into my teenage years. I'd been exposed to the idea of a catastrophic end to their reign on Earth through the medium of a popular toy of the 1950s. It was called the Viewmaster. This was a plastic viewer that allowed one to see images in 3D. I can still remember well receiving a Viewmaster as a present for my 5th birthday. Included with it was a set of 3 reels illustrated with scenes from the 1956 documentary Animal World, a Warner Brothers movie that contained an extensive sequence of stop-motion animations of dinosaurs during the Mesozoic era. Now, the Mesozoic, I will mention, is the great era of middle life, Mesozoic. Meso means middle, zoic means life, and it came after the Paleozoic, or old life, and preceded the Cenozoic, or recent life. So the Mesozoic, the end of the Mesozoic coincided with the end of the Cretaceous period, at which the dinosaurs were killed off. So significant was and far-reaching was of this event that a whole great life era is now considered to have come to an end. Anyways, back to this Viewmaster reels that I had when I was 5. This one particular one that was illustrated with the scenes from this movie, The Animal World, the sequence about dinosaurs ended with scenes of the destruction of the dinosaurs in a fiery catastrophe. The booklet accompanying the Viewmaster describes the climactic scene, which follows a battle between a Tyrannosaurus Rex and a Triceratops. Now, Triceratops, you remember, is the 3-horned with the great shield and so on. You might remember, if you saw the original Jurassic Park movie, there was an ailing Triceratops in there that the heroine was going to try to nurse back to health or something, if I remember right. But anyways, that was a Triceratops. So now, in this great battle, the Triceratops has already delivered one blow with one of its great horns, wounding the T-Rex. But before it can deliver the killing blow, and I quote from the little narration it came with it, a booming roar shook the air, and the very sky caught fire. Even the battling monsters froze in the middle of their fight. The earth under their feet rose and fell like the waves of the sea. The blue of the sky had vanished in a blood-red deluge of light, and the silence was broken by the booming of vast explosions in the distance. Mountains blew their tops. Flowing lava engulfed many dinosaurs, and ashes killed the plants to starve even more. Great cracks opened up in the ground. The doom of the dinosaurs was at hand. Winter came back into the world. In the cold, the dinosaurs grew sluggish, and many perished." Unquote. Interestingly, now they don't mention a cosmic impact by specifically, yet all of the secondary consequences of such an impact are very similar to what is being described here, even to the fact of the winter, the so-called cosmic winter coming into the world in the aftermath of a great impact. So the scenario now for the extinction of the dinosaurs is, yes, the initial impact would have caused a major die-off. The secondary fires produced by the fallback debris would also trigger more deaths, but then the canopy of dense soot and material from the great fires and so on, and the material injected into the atmosphere from the impact itself, would have caused a veil to surround the Earth, a canopy, if you will, that would be reflecting the sunlight back into space, causing the world to plunge into a cosmic winter. So this particular narrative finished by raising a question that continued to marinate in my brain for decades. Quote, "The total disappearance of the dinosaur is one of the great mysteries of all time. Their complete extinction cannot be explained. This whole race of reptiles, which dominated the face of the earth, its waters, and its atmosphere for 100 times as long as the short span of man on earth, this whole race died out, leaving not one single descendant." Unquote. So, when the news came out in 1980, scientists had found the fingerprints of a cosmic event at the very boundary that marked the sudden disappearance of the dinosaurs, I was instantly captivated. The evidence came in the form of iridium, a platinum group metal that is rare in the Earth's crust, but abundant in meteors and asteroids. This discovery led to a controversy that raged over the next decade, with critics arguing for a less catastrophic, more protracted extinction event than would be implied by the sudden violence inflicted upon the planetary environment by the impact of a large asteroid. However, as scientists continued to examine the KT boundary, as it is called, or at least was called then, they repeatedly encountered the presence of abundant iridium along with other evidence of impact. Based upon the amount of iridium deposited worldwide, it became possible to estimate the size of the impactor or bolide necessary to deliver that quantity of iridium to the biosphere. It turned out that the object would need to be about 6 miles in diameter. This makes the KT cosmic object roughly 9 or 10 million times the volume of the Tunguska object that exploded over Siberia in 1908 with the force of a 15-megaton nuclear bomb. The power of an impact on this scale is unimaginable. It would literally have set the sky on fire, produced global earthquakes likely, and volcanism, produced extreme acid rain, and would have been followed by a temporary but intense cosmic winter due to the sheer volume of dust and soot injected into the atmosphere, blocking the sun. The scenario that evolved through many interdisciplinary studies as to the environmental effects of the KT impact was not at all unlike the vivid description in my little Viewmaster toy story that so captivated me way back in 1956. However, even as indirect evidence continued to mount throughout the 1980s in the form of impact proxies, supporting the idea of an abrupt demise of the dinosaurs and a global ecological breakdown at the same time, critics refused to admit the possibility of cosmic impact without a smoking gun in the form of a crater, an impact crater. This changed, however, in the 1990s with the discovery and confirmation of a giant astrobleem or star wound buried under the Yucatan Peninsula that was of the right size and the right age. At this point, many of the critics were convinced. As studies continued on the extraordinary events at the KT boundary, it is beginning to appear that for a period of time, the Earth was undergoing multiple impacts during an episode of clustered bombardment, though the Yucatan strike appears to have been the most severe. It is also important to appreciate the fact that the Earth was, at the same time as this bombardment, undergoing, as we talked about, one of the largest, most extreme episodes of volcanism in the history of the planet, during which the so-called Deccan traps were extruded. So the traps are a massive deposit of layered flood basalts, originally covered as much as 600,000 square miles of lava that were up to 6,000 feet thick and encompassed as much as half of the subcontinent of India. Is it possible that the great eruptions such as the Deccan traps were triggered by the impacts of asteroids and or comets?